let's do some logs. What a lot of you guys will find is that the calculus is not the hardest part of the class. It's all the algebra 2, the pre-calc, and it's kind of like algebra on steroids and the calculus. It's actually easier for most people. So let's start looking at logs, because that tends to give some people some problems. So first thing you got to be able to do is rewrite logs and understand how they go back and forth between an equation that's just powers. Logs are just powers. So let's say I had log base b of x equals y. Well, all that means is you do this little circle move, and that would be whatever b is to the power of y equals whatever x is. So whatever's in that spot. So the first thing you got to be able to do is just understand how to rewrite them and go back and forth between those two forms. Usually you're going in this direction, but it helps you understand it if you can go backwards too. So let's say I gave you, log base 8 of 64 equals 2. You would need to be able to rewrite that in this power form. So it's just going to be the same kind of pattern there. So 8 to the second power equals 64, which we notice is true, right? So if you try to do that like 64 to the second equals 8, that wouldn't make any sense. So realizing that it has to be true kind of helps you realize how to do it too. Let's say log of 1000 equals 3. So if there's no number here, that's what's called a common logarithm, and it doesn't need to be written if it's a 10. So if it's a 10, they're going to leave that blank oftentimes. And so you would need to be able to realize that this is 10 to the third equals 1000. If it's ln, so let's say ln of e to the fifth equals 5, and you were asked to rewrite that. If it's ln, they're not going to write what goes down there either, but in this case it's an e. So natural logs are always e's. So if I rewrote this, let me go back here and do that little pattern for you. Do the same pattern, so e to the fifth equals whatever's in this spot, which is e to the fifth, and all that's saying is e to the fifth is equal to itself, which is true. If you had to go the other way, let's say 3 to the negative second equals 1/9. So let's talk about that for a second. Remember, negative exponents flip things over. So 3 squared would be 9. But because it's a negative exponent, it doesn't make the answer negative, it gives it a reciprocal. So it flips it. So 3 squared would be 9. 3 to the negative second is 1/9. Now if you had to write that in this pattern here, you're just kind of looking at what we have above and trying to undo it. So the base goes down here, the power goes on the other side, and then you got your 1/9 there. So if you try to rewrite it, 3 to the negative second power equals 1/9. All right, you should be able to evaluate them. There are 3 variables in that equation. We got the b, the x, and the y, and I can leave any one of those blank and ask you to find it. So for example, I could say, what's log base 3 of 81? That's the most common way, is we leave the equals y blank. So the first thing I would ask you to do is write the equals y, so it's in the form that we're used to. And then take that and write it into a power. So a power equation. So 3 to the y equals 81. And then at this point, you're kind of just trying to go through your powers in your head and figure out 3 to what power gives you 81. So 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81. So what's technically happening is you're saying 3 to the y equals 3 to the fourth. The 3's cancel, and then you get y equals 4. You don't have to show me this stuff if you don't want to. It just might help you understand what's happening. Let's say log base 2 of 1/8. Again, as always, if you want to pause the video, try this one now and then unpause it after you've tried it and see how you did. I think that's a good idea. If you're not ready for that, don't worry about it. I'm going to put the equals y there, and then I'm going to rewrite it. So it's going to be 2 to the y power equals 1 over 8. So now there's a couple of different things going on here. It is flipped over. The 8 is on the bottom. So because it's a fraction that's flipped over, our answer is going to be negative. So first you're trying to figure out 2 to what power gives you 8. So 2 squared is 4, 2 to the third is 8. So there's got to be a 3 in there somewhere. But the 3's got to be negative because we're flipped over. So your answer is actually negative 3. If you're interested in seeing how that gets written out, you could kind of start like this. And then when we bring powers up, we change their sign. So 2 to the y equals 2 to the negative 3, and then those cross out, and your answer is negative 3. If I left the variable in a different spot, so let's say log base b of 64 equals 3. You're going to do the same thing. Your approach is the same. That circle is always helpful to use. It's not really a circle the way I drew it there, but that's okay. So b to the third power gives you 64. And then you're just kind of running through, okay, what is it to the third power that gives me 64? Well, I know 2 cubed is 8. 3 cubed is 27, so we're still not big enough. Well, 4 cubed is 64. So technically what's happening is this. 3 is cross out and you get b equals 4. But you don't have to show me that stuff. It's just kind of there to help you figure out what's happening. Let's say log base b of 1/9 equals negative 2. So again, the first thing I'm going to do is throw it into a power equation. So b to the negative second equals 1/9. And you can kind of reason through it, or you can, I'm going to show you how to do it in the fraction form and write out your steps too. But so the first thing I'm thinking is, okay, it's negative. That means our answer is flipped over. Well, our answer is flipped over. So that already puts me on the right track. And then I'm saying what squared gives me 9? And the thing squared that gives me 9 is 3. So the answer is going to be 3, because if I took 3 to the negative second power, 3 squared would be 9. The negative would flip it over and you get 1/9. What it looks like if you write it out would be more like this. I'm trying to match up these numbers. So if that's a negative 2, I'm going to make this a positive 2. If I bring that up, it's 3 to the negative second. Your negative 2's cross off, and you get 3. All right, let me go take care of that, and I'll be right back. Okay, so I could leave the variable in the third spot too. So I could say log base 7 of x equals negative 2, for example. So the variable's here. And it's just powers. It's the same rewrite, and then you're just working with it from there. So 7 to the negative second equals x. And then x is by itself, so you just got to figure out what 7 to the negative second is. Well, 7 squared is 49. Remember, the negative exponent flips it over. So this will be 1 over 49 equals x. And that's your answer. All right, let's say log base 8 of x equals 2/3. So we're going to get a fraction power, which is something that people sometimes have a hard time with, so it'd be good to go through one of those. Maybe a couple of those. So if I rewrite it, I get 8 to the 2/3 power equals x. So I got to figure out what 8 to the 2/3 power is, and you don't have a calculator. You're not allowed to use your calculator. So the number on the bottom is always the root. Let's kind of go over here and make notes here. If I have just a number to the, let's say m over p power, let's say p over r power. The number on top is the power. The number on the bottom is the root. You're always going to do the root first and the power second. So this is asking you for the third root of 8. So what number to the third power gives us 8? You're kind of unpacking the 8 down to like what its base is. So the number to the third power that gives us 8 is 2. So that's the third root of 8. That gives us 2. Now you take that 2 and you raise it to the power that's on top. So we got 2 from this root. We do 2 squared. And our answer ends up being x equals 4. Let me jump through another one of those. And again, pause if you need to, rewind, try this out. Hopefully these videos are helping you go at your own pace. So let's say log of 25, log base 25 of x equals, I'm going to throw a negative in there too, equals negative 3/2. So if I rewrite it, 25 to the negative 3/2 equals x. So x is by itself. We're good there. My job is to figure out what 25 to the negative 3/2 power is. I'm going to leave the negative for last. Remember, the negative is going to just flip our answer over. It's not going to make our answer negative. It's just going to flip it. So I'm going to kind of forget that's there and worry about these two. So this is the second root. So the root's on the bottom. Power's on top. I do the root first. So the second root of 25. The second root is square root. So the second root of 25 is 5. Then I take that 5 and I raise it to the power on top. So I do 5 to the third power. 5 times 5 times 5 is 125. Then I worry about the negative. And my answer would be negative. I'm sorry, not negative. The answer would be 1 over 125. All right. Okay, the last thing you'd ask to be able to do with these would be to condense them or use these log rules. And there's 3 of them that I'm really interested in you. There's 3 of them. 3 is good. If I have log base b of x plus log base b of y, that becomes log base b of xy. So addition combines to be multiplication. Where that might be useful is if I had something like log base 5 of 2 plus log base 5 of 12.5. Well, I don't know. So 5 to what power is 2? I don't know. That's going to be some goofy fraction. 5 to what power is 12.5? Again, I don't know. That's going to be some weird fraction or decimal. But this rule says that because it's addition, I can combine these two numbers using multiplication. So 2 times 12.5 is 25. Now it's saying what's log base 5 of 25? Well, if I throw that equals y there, it says 5 to what power equals 25? And my answer is 2. So that's why these might be helpful. You also might just be asked to rewrite them. So if I just say like log base m of x plus log base m of y, you would be expected to know that's the same as log base m of xy. All right, I guess kind of the opposite of that. And I should mention that if these bases aren't the same, the rule doesn't work. Excuse me. So when you get presented with the situation, they're going to be the same like 99% of the time. If they're not, we can figure out a different way, but usually you can combine them because they're the same. So let's say it was log base b of x minus log base b of y. Well, that just combines to be, if addition combines to be multiplication, then subtraction combines to be division. You're always dividing the first thing by the second thing. So an example of when you might use that would be, let's say I have log of 500 minus log of 5. Remember, if there's not really a number down there, it's a 10. So this is like 10 to what power equals 500? Well, 10, if I start multiplying by itself, it's never going to land on 500, and it's never going to land on 5. So I need a calculator, I got decimals going on, it's going to be tough. So this rule allows me to say, okay, well, that's really log of 500 divided by 5, which is really log of 100. And then again, remember there's a 10 down there. Put your equals y, so it's saying 10 to what power equals 100, and we know 10 squared is 100, so our answer will be 2. Okay, the third rule is the power rule. So what this says, if I have log base b of m to the x power, let's say, let's use a different letter. Let's say m to the c power. What you are allowed to do is take that power and put it in front and rewrite this as c times log base b of m. And you can go either way with that. But where this is useful, I guess that's an example, that's the rule, is if I had like log base 2 of 8 to the 15th power. It is possible to figure out what 8 to the 15th power is, and then figure out 2 to what power gives you that. But that's ridiculous. I mean, no one, it would just be way too hard, take too long. So what we can do is say, okay, I don't want to do 8 to the 15th power. So I'm going to take that 15, drop it in front, and then I'm going to work out this part. So 2 to what power gives me 8 is 2 to the y equals 8. So 2 to what power gives me 8 is 3. So that part here gives me 3, and then 15 times that 3 gives me 45. If you had log base b of x to the 1/2, this could be a situation where there's, you have to rewrite it, but you can't really solve it because you don't have enough numbers. That would be the same as if I took that 1/2, dropped it in front, and did that. All right, so hopefully that helps you with logs. Again, that's just an advanced algebra pre-calc thing that people often need reviewed, so we're taking some time to do that to make sure we get that straight going forward.